Hi Year 7. This is the first in a series of 5 videos that I'm going to do on the topic angle relationships. In this first video, we're going to look at conventions in geometry. So what is geometry? Well, it's the branch of mathematics that deals with objects in space. And this will include points, lines, intervals and rays, angles, plane shapes, and solid shapes. And here's a little cartoon for you. Talks about sacred geometry, which is geometry that's connected to religion, and scared geometry. Do you like the pun? So we'll start with the simplest structure, which is a point. It's just a position in space, and it has no dimensions. Now, what do I mean by that? Remember how we live in a three-dimensional world? We have length and breadth and height, but a point has none of that. It has 0 dimensions. Now we label a point with a capital letter, so if we draw a representation of a point, like here, we would call this point A. An interval or a line segment joins 2 points together, and it has 1 dimension, which is length. Now this is the interval AB. We name it by using the 2 letters that are given to the endpoints. If we have 2 intervals that are the same length, then what we do is draw a small dash on each line to show this. So we could say that AB is equal to CD. If we take our interval and extend both ends to infinity, we get a line. We indicate this by putting arrows on the ends of the line. A line is named by using the letters of any 2 points that lie on the line, and so this is line AB. But we could also call it line BA if we wanted to. Now I'm sure you remember this. Parallel lines are the same distance apart. They never meet. And if we want to show that 2 lines are parallel, we'll draw an arrow on each of them, like this. To state that 2 lines are parallel, this is what we write. AB is parallel to CD. Perpendicular lines are lines that are at 90 degrees to one another. And on the diagram we use the right angle symbol, which is this little square here. And this is what we write if we want to state that 2 lines are perpendicular. AB is perpendicular to CD. Now here's something you might not know. A ray is part of a line. It's fixed at one end, like this one here is at A, and goes off to infinity at the other end. So this would be the ray AB. Okay, we're up to angles. An angle is formed when 2 rays meet. And you can see that here. We've got the ray AB and the ray CB, and they both meet at this point B. The point where the rays meet is called the vertex. And the rays are called the arms of the angle. And so the arms of this particular angle are AB and CB. And just to review, there are 6 special angles that we identify. There are acute angles, which are less than 90 degrees. There's a right angle, which is equal to 90 degrees. Obtuse angles are in between 90 degrees and 180 degrees. A straight angle is equal to 180 degrees. Reflex angles are in between 180 and 360 degrees. And finally, a revolution is equal to 360 degrees. To name an angle, we use the letters given to the points that make up the angle. Now, if there's no confusion, we can just use the capital letter that's at the vertex, which in this case is B. So this would be angle B. Or we can use 3 letters, making sure the vertex is in the middle. So we could say this is angle ABC, or we could say it's angle CBA. Both of those would be correct. And you can see how we've put an angle symbol at the front. Angles can be formed from multiple rays. And you can see in this diagram that 3 angles have been formed. There's this one here. There's this angle here, and there's also the outside angle, this one. Angles can also be formed from lines intersecting one another. That means to cut across. So you can see here that 4 angles have been formed when these lines cross one another. Now in these cases, these angles are said to be embedded, and that just means that they're inside another angle or another shape. And the really important thing about embedded angles is that we can't use the single vertex letter to name the angle. So we can't say that that angle there is angle B, because it will be ambiguous. And remember, ambiguous means confusing. If I say angle B here, am I referring to this angle, or this one, or the outside angle? Because they've all got vertex B. So we have to use 3 letters. So that highlighted angle there could be angle CBD, or angle DBC. Here's another example. Name the highlighted angle. Now I just want to point out that we're not being asked the type of angle. Okay, we're not being asked is it acute or obtuse or reflex. We're being asked its label. So we start at one of the arms, go through the vertex and end at the other arm. So this would be angle BCD or angle DCB. To show that 2 angles are equal, we mark them with the same symbol. So these 2 angles here are equal to one another. We could just mark them with an arc. That would show that they're equal. Or we could mark them with the same symbol. That's the Greek letter alpha. And this is what we'd write. Angle TUV is equal to angle WXY. But have you noticed this? Okay, because these are not embedded angles, we could just write angle U is equal to angle X. Now, if there are 2 pairs of equal angles in a diagram, all we have to do is use 2 different symbols. So this shape is a parallelogram, and opposite angles are equal in a parallelogram, but they're not all equal to one another. So here I've used a single arc to show that these 2 are equal to one another, and here I've used a double arc to show that these 2 are equal to one another. Now it's the same with sides. So these 2 sides are equal and these 2 sides are equal. And lastly, the size of an angle is a measure of how far one arm is rotated from the other. So in other words, how far is CD rotated from ED? Now angles are measured in degrees, and to measure them we need to use a protractor. And what we do is we line up this part of the protractor, which is called the crosshairs, with the vertex. And we make sure this baseline lies along one of the arms of the angle. Now there are 2 scales here you can see. There's one that starts at 0 and there's one that starts at 180 degrees. It's really important that we always choose the one that starts at 0. And then we just measure around until we hit the other arm, which is about 45 degrees. And then we would write angle CDE is equal to 45 degrees. Okay, that's the end of this video. In the next video, we're going to look at some special types of angles that are called angles at a point.